All right, guys, good morning. Lesson 2, starting on page 15. Continuing to talk about functions, more of an intro here. It says, here are some numbers in a list. How many different numbers are in the list? I'm assuming we can get that one. Another thing, make sure we're taking notes here, of course. That's the whole point of this video and even class on a daily basis in general, so you can have notes when we get to an open book quiz and test. It'd be pretty silly not to have these filled out. So please make sure you're taking good notes. Gavin and Ian, I'm hoping that by day 2 here, we still have our books with us and haven't lost them yet. So keep tabs on them here if we can. It is rather a long unit, so expecting big responsibility from you here semester 2. But how many different numbers are on the list? Nobody should get that one wrong, right? Just count them. Well, there's 7 numbers in the list. Make a new list squaring all those numbers. Remember, that means just times itself. So 1 times 1, or 1 squared, is of course 1. -3 times -3, 9. How about -1 half times -1/2? Remember, two negatives make a positive. That's why we got a positive 9 there. Half times a half is of course a fourth. 3 times 3, 2 times 2, 1/4 times 1/4. Half times a half, or 0.5 times 0.5 would be a quarter. We'll just leave it a decimal. How many different numbers are in this list? Well, I still have 7 numbers, but it does say how many are different. I have 9 twice. I got a quarter twice. So 7 minus 2 would be 5 different numbers. Explain why the 2 lists do not have the same numbers. So how come I started with 7 different numbers and now I have 5? Well, because some numbers in the list are different because they have the same square. All right, -3 is going to produce the same answer as 3. -1/2 and +1/2, because you're squaring them, it gets rid of the negative, will give you the same answer. So that would be why for question 1. Question number 2, say yes or no, and draw a little input-output diagram, the little function box like you've been seeing here. It says a person is 5.5 feet tall. Do you know their height in inches? Well, I sure think we can figure that out. Okay, and then it wants me to show how. Well, if you're 5.5 feet tall, you would have to multiply it by 12. And what do you get? Because we know there's 12 inches, of course, in a foot. 12 times 5 would be 60, and half of that should be 66 inches would be our answer. The number is 5. Do you know it's square? Yeah, we can certainly figure that out. You could say square it, I suppose, or times itself. 5 times 5 is 25. A lot of people get that one wrong. They'll think 10. It's not 5 times 2, it's 5 times itself. The square of a number is 16. Do you know the number? Well, this one we'd have to say no, because I know it could be 4, but it could also be -4. I give you the same answer. Okay, so that one we could not draw because it could be 2 different things. Number 4, a square has a perimeter of 12. Do you know its area? Should be able to figure that out. All right, if you have a square and the perimeter is 12, Well, first thing you have to do is get its side length, right? So you have to take 12 divided by 4. 12 divided by 4 is 3. Every side is 3. To get the side length, and then you'd have to square it to get the area. 3 times 3. So 12 divided by 4 is 3. 3 times 3 is, of course, 9 would be my answer. A rectangle has an area of 16. Do you know its length? Well, again, it's going to be no because there are more possibilities, right? It could be 1 times 16. It could be 2 by 8. It could be 4 by 4. So there's multiple answers that could give you that, so we got to say no again on that one. You are given a number. Do you know the number that is a fifth as big as that? So yeah, you'd be able to give that. So it gives you a number. Doesn't matter what it is. You want to know what's fifth as big as that? You take it times 1/5. And then you get your output, or your answer. Doesn't tell us what number to plug in there. You are given a number. Do you know its reciprocal? Remember, reciprocal, if you give me 3, would be 1/3. If you give me 5, would be 1/5. If you give me 1/7, it would be 7, and so on. So whatever number it gives you, you flip it over, and you get your output. All right, so if it's 3 over 1, you flip it over. If it's 1 over 7, you flip it over. Okay, always the case. Question number 3. Here are some questions from the previous activity. The ones you said yes to, write a statement like, the height of the rubber ball bounces to depends on the height it was dropped from. Bounce height is a function of time, so basically we're going to write sentences for the ones that we wrote yes to. It also wants no to. So just writing sentences here on page 17. So again, we said yes for this one. So our height in feet depends on height in inches. This one was yes as well. The square of a number depends on the number. This one was our first no. Knowing the square of a number doesn't determine the number. Right? Remember, it told us it was 16 here, but it didn't. I mean, we couldn't tell which one the answer was, so cannot figure that out. Square has a perimeter of 12. Again, this one was yes from the previous page. The area of a square is determined by the perimeter of the square. This one is again no, our last no. Knowing the area of a rectangle, excuse me, does not determine the length. Remember the other possibilities we could do there. This was yes. Every number determines a number that is 1/5 as big. Yes. Every number Actually, better say not 0. Remember, if you flip over 0 or 0 over 1, it comes 1 over 0, and you can't divide something by 0. That's impossible. All right, you can't take your homework and rip it into 0 pieces of paper. It doesn't make sense, or cut a pie into 0 pieces. So every number not named 0 determines a reciprocal. All right, next one. Which ones are describing the same thing? 7 squared, right? 7 squared, you get 49. Find the area of a given side length. Okay, so 10 times what would give you 100? That'd be 10 squared. And 10 plus 90 to get 100. So which ones are the same? Well, of course, it's the 2 that are squaring it. Both of those are squaring it. 7 squared to give you 49, 10 squared to give you 100. This one, you're just adding. You can skip the are you ready there, and let's just look at the summary. It says, let's say when we have an input-output rule for each input, that gives exactly one output. We say that the output depends on the input. Okay, that is the terminology we will use. The output is a function. So for example, the area of a square is a function of the side length, because you cannot find the area from the side length, but you can find the area from the side length by squaring it, right? 10 squared, this is the one we just did, is 100. Okay, so it is dependent upon what this is. So let's look at the examples then. Your homework, starting on page 19. First question, calculate the output when you use -6 as the input. So if I plug in -6, do this to it, what do I get? If I plug in -6, do this to it, what do I get? So you're plugging in -6 to each one of these boxes. Question number 2, there are 4 of them. It does go on to the next page. It says true or false and why. Make sure you explain why to get credit. Okay. So let's look at the first one. Speed is a function of times. A group of students is time while sprinting 100 meters. Okay, so you are timing every person. So speed is a function of time. So that one is going to be true. So every time that's collected, every time I click the stopwatch, I will get 1 speed. Time is a function of distance. Okay, so if this is a function, if this is true, that means every distance, in this case it's 100 meters, there will only be 1 time. Okay, so if I am timing all these students, they're all running the same amount, is there only going to be 1 time? That means will everybody run at the exact same, or finish at the exact same time? Absolutely not. So that one is false. Every distance produces many times. All right, I can only have 1 output in order to be a function. There can be a lot of different times for people running 100 meters. All right, same thing for C and D, true or false there. Question 3. That is a little review from Unit 4. I think you can handle that one. There'll be 2 equations. And then you'll solve it. You will get whole numbers there, I believe. So I don't think any fractions or decimals are required. And question number 4. Which of these input-output tables could represent a function rule? That means if you plug in an input, you just get one output. If the input goes to different numbers, then of course we have an issue, right? I can't plug in 1 to an equation and get -1, and then plug in 1 again to the same equation and get something different. That's an issue. That is a red flag for functions. It cannot be a function. If I plug in 1 to an equation, I better get the same answer every time. Okay, so just keep that in mind when you look at that. 2 of them make functions, 2 of them do not. So 1 through 4, guys, for tomorrow, please. Nope, excuse me, that'll be for Monday.